In this presentation, we're going to discuss embedding the graph K5 on the Mobius strip. This example is similar to the example in the book, section 9.2, embedding graphs on surfaces. In the example in the book, they embed the graph on the torus. The torus is easier to see the embedding, but the torus is difficult to construct. So in this example, we're going to be able to build the Mobius strip from a piece of paper, and that way we have a visual aid to see how the graph K5 is embedded on the Mobius strip. So the first step in this presentation is we'll define how the Mobius strip is constructed from a rectangle. From there, we're going to sketch the graph K5 on this rectangle so that we can build a Mobius strip from a piece of paper. And then finally, we're going to build the Mobius strip using paper and tape. The Mobius strip can be defined as a rectangle with its sides identified using the relation presented on the slide. We can see that based on this relation, the red circles are identified, meaning that they correspond to the same point, and the same thing for the purple circles. So if we were to draw a line on this rectangle, if we were to go meet this red point, the line would continue on the other side of the rectangle. So if we're going in this direction, we would come out on this side. Now that we understand how the Mobius strip is constructed, we can sketch K5 in a way such that the edges do not intersect by taking advantage of the properties of the Mobius strip. So for example, if we look at node number 1, we have an edge that is leaving node number 1, proceeding to the edge of the rectangle, and then continuing on the other side of the rectangle to reach node number 4. And similarly, we have an edge leaving node number 2, proceeding to the edge of the rectangle, and then continuing on the other edge of the rectangle to meet node number 3. In the previous slide, we showed how the graph K5 can be embedded on the Mobius strip. The remaining slides of this presentation, we will show how to build a visual aid using paper that has the graph K5 embedded on a Mobius strip. So the first step in the construction is to cut a thin strip of paper. And this is easiest if you have a long, thin strip of paper because it's easier to twist when constructing the Mobius strip. And then as a second step, make small marks approximately 1 centimeter from the top and bottom to use as reference when sketching the graph. The next step is to sketch the graph K5 just as we saw it in the previous slides. I use different colors for the longer edges because it makes it significantly easier to track what's going on once you have the Mobius strip constructed. The next step is to flip over the piece of paper and trace the lines that you drew on the other side. It's important to understand that the Mobius strip is a surface with only one side, and this tracing step is just a result of constructing the Mobius strip on a piece of paper. We are only tracing this to allow us to see what is on the surface from either side of the paper. The Mobius strip is different than a sphere in the sense that the sphere, you're always looking down on the outside of the sphere and you're never looking at the surface of the sphere from the inside. Since the Mobius strip is twisted, you can see the surface from both the outside and the inside. The Mobius strip has lots of interesting properties, and I would suggest looking at reference material from a topology course if you would like to learn more. One interesting property of the Mobius strip is that it is an example of a non-orientable surface, and this is demonstrated in the animation on the right, where we see the fiddler crab who has a large claw on the right side until it transitions around the Mobius strip, where we see that the large claw moves to the left side. The non-orientable property is what allows us to embed the graph K5 onto the Mobius strip without the edges intersecting. If you'd like to learn more about the non-orientable property, take a look at the video Non-Orientable Surfaces, the Mobius Band, provided by NJ Wildberger on YouTube. This video is linked at the bottom of the slide. The final step to construct the Mobius strip is to take the ends of the paper, twist one end, and then tape them together. You now have a Mobius strip with the graph K5 embedded on it. On the slide here are a couple of pictures of the Mobius strip that I constructed. Thank you for watching, and I hope you enjoyed this video.